So good morning, good afternoon, good evening, wherever you're joining us from. My name is Alistair Gordon. I'm one of the product managers here at Deep Casing Tools. And with me, I've got Eoin Wood, who's our global sales and marketing manager, as well as Dave Charles, our in-house well engineer. And today we're going to be taking you through the subject of our webinar, which is innovative approaches to ensure operational assurance. So with that, Dave's going to start and take us through a bit of a discussion. With Dave's experience that he's got with drilling extended reach wells, very recently for MechLOK Offshore, very famous operator, he's going to go through and take us through how operational efficiency, is needed and the ways that they do that. Dave.
Yeah, thanks, Ali. So, of course, there's a great effort put in place by oil companies to engineer wells to run casing, liners, and completions to TD first time. There's all the planning software that's used by drilling engineers and completion engineers to do the well planning up front. All this goes around, very often minimizing stresses that are affecting the wellbore, especially when you're running casing, liners, and completions. You want to try and minimize the damage that you're inducing to the near wellbore environment, because that's very important to ensure that at the end of the day you get a good cement job and that the well integrity is assured, and that's going to minimize your well costs for your actual well, and also for the ongoing cost of the well when it becomes a producer and injector. So getting liners and TDs to the getting to TD first time, you want to minimize your wellbore stresses with minimizing your swab and surge cycles, which can cause borehole instability, can cause pack-offs when you're trying to circulate your cement. So there's a lot of planning goes into this, and at the same time there's the operational excellence, the way that the speed that you run your casing, your liners, and your completions to ensure they get down there first time. Because if you get the casing down first time, if you have to pull your casing, pull your liners, or pull your completions, this does a lot of forces are being exerted on your near wellbore environment that will make it harder for you, especially to run any of these tubulars a second time. It never gets easier. So getting there first time is really important. And again, as I said, with regards to well integrity, getting a good cement job makes a big difference to not only continuing the well, but also to the management of that well for the foreseeable future. If you look at the sustained casing pressure that you sometimes get in wells, that causes an awful lot of problems in future, but can be very costly to fix. So you want to minimize fluid losses, either into intermediate sections, into formations that do damage. And so that's managed. You're managing that with the speed that you run your tubulars, and also when you're in your reservoir, you don't want to damage your reservoir formation because that can affect your overall permeability in zones and prevent you from achieving your production goals. So all of this fixes into the overall well cost. And of course, if you have to pull your tubulars, this will result in possible damage to centralizers, any elastomers that you have. If you're having to pull a liner, packers, and hanger equipment, and if you're pulling a completion and it's got swell packers on it, again you've got issues with your elastomers. So it's very costly to have to rerun any of your tubulars or completions when you're trying to finalize the well. And there's specialist companies out there that help with complex and ERD wells, and oil companies put a lot of effort into ensuring that their operational stages are completed successfully and that nothing's left out. So I think we all know what these challenges are, and we all know the benefits of getting our casing, liners, and completions to TD first time, and that's what Deep Casing Tools specializes in with our turbine powered reaming shoes and our drill pipe swivels. All right, Alan.
Okay, so thanks very much, Dave. As you've seen there, a poll came up that we asked you to participate in during the talk there. Obviously, the question being, can innovative technologies contribute positively to operational assurance? Thankfully, the resounding result are yes, it does. And with that, we're going to now go on and talk about some of our downhole technologies to help improve this operational assurance. I'm going to pass back to Dave, who's going to take you through our. Oh, sorry.
That's right. No, so I'm just glad we're all in agreement.
Pass you back to Dave, who's going to talk about our downhole turbine reaming shoes. Dave.
Yeah, so when we're managing wells and we're planning wells, and we're taking care of torque and drag and the hydraulics, the slot and surge forces, and working with the geomechanics and the geopressures. We have a lot of knowns, but we have some unknowns, and this can result in coming across obstructions when we're running our casing liners or completions into the wellbore. Very often you won't have the optimum casing program. You've maybe got 3 strings of casing rather than 4 or 5 strings of casing, in which case you're very often having to balance the maximum mud weight that you have in the hole versus the mud weight that you can run in the hole. So to stabilize the formation. So of course, using a drill pipe swivel and managing your torque and drag and your forces is one thing, but what happens when you come across an obstruction? That's another issue. And for that we have turbine powered reaming shoes. We've got our turbo caser, which is designed for intermediate casing strings or liners, and it's drillable. And then we have got our final string turbine powered reaming shoe, our turbo runner, which is for running liners and completions to TD. Both have a highly convex shaped reaming shoes, which are good for riding over ledges and avoiding sidetracking. Both use small PVC cutters, and they're basically designed to minimize wellbore stresses. Earlier on, I mentioned how minimizing the cyclical borehole stresses, avoiding pack-offs and pressure surges is very beneficial to the casing and cementing, and especially when you're talking about completions. So we both have small PVC cutters that these turbine powered reaming shoes are operating at a very high RPM. The small cuttings that are being generated are unlikely to cause any pack-offs and pressure surges. They both operate very effectively with high RPM, relatively low torque. Both have secondary flow paths to them, so we're talking about assurance. So what happens if you're running one of our turbine powered reaming shoes and for whatever reason the turbine stages got blocked up? Well, we have a secondary flow path. There's a burst disc that's engineered to have the right pressure to burst at. And what it will do, it will protect you, guarantee and assure that you have a secondary flow path. And it will also guarantee against setting any of the, if you're running a liner or a completion and you've got a packer or a hanger, it'll make sure that you don't accidentally set that packer at the wrong depth.
David, just sorry to just jump in here, but I mean, from your experience as a drilling engineer, obviously being in Mexico and Abu Dhabi, how many instances did you come across where you didn't hit TD first time, and you could have done with that kind of assurance, so to speak?
Personally, yeah, I had quite a few wells where we didn't manage to get to the planned TD first time with our casing or liners. And very often, and what's happening today is the oil companies are pushing the drilling envelope. They're trying to drill further and further away from their where their wells are aggregated to optimize cost and cost efficiencies with those wells. So we're seeing wells that are being drilled up to 50,000 feet now, and that can very often involve going to high inclinations in surface and intermediate casing, So the challenges are increasing with time. And so what worked, one type of design, once you try and extend it, that design doesn't work anymore. And there's a bit of learning, empirical learning there. And that's what you can also learn when you engineer the wells. So, we have tools that, so it's, yes, there's the operational excellence, but at the same time, I think there is a definite place for having tools in there that can help you overcome, in this case, obstructions that you can come across where you've had swelling shales or you've had borehole instability, because you are stretching and pushing the envelope, the drilling envelope, with regards to the mud weight and the geomechanics. So with our turbines, we find that as a very effective solution to either get casing liners or completions to TD. They're designed in a way for, and again, we're talking about assurance, we've got that secondary flow path through them. So regardless of what happens, we're going to be able to pump drilling fluid or cement and spacers through our tools. We're going to prevent any unplanned hydraulic mechanisms being activated. You can install a turbine as many times as you like. It's a pressure drop. There's no pressure spike that can affect your equipment. And as I said, we've got burst discs in there that will ensure that there's a flow path and also protect any hydraulic equipment. And when it comes to drilling the next section with the turbo casers, we have a locking mechanism so that regardless of whether the shoe is wet or the cement is green, that you'll 100% of the time you're going to be able to drill out that shoe and carry on into the next section.
We had a classic example of that there just at the weekend, Dave. Over in the Middle East where we had absolute green cement in our turbo caser and we still managed to drill it out, flawlessly. So that's the definition, I guess, of operational assurance. No matter what the cement state is around your shoe, there's no issue drilling that out.
So just to summarise, we talked about the geomechanics, the wellbore stability, planning your well, the fact that wells have become longer and more complex. We can manage things like the side forces and friction factors with, and you're going to talk about the drill pipe swivel. But there's things that you sometimes can't plan for where you have had some wellbore instability and you do come across an obstruction. And that's something that's very easy to engineer. In this case, that's when it's important to have tools that can overcome those obstructions and get your casing liners and completions to TD first time, as we have been doing for the last 13 years.
Awesome.
Okay, thanks very much, Dave. So just before we get Eoin to go and talk about our other products, the MechLOK, which is for helping you get your completions to TD. If you do have any questions, please do go ahead and use the Q&A button. And we've got a Q&A section at the end of the webinar that we can go into. So Eoin.
Yeah, sure. Thanks, Alistair. Much appreciated. Thanks, Dave. Very informative about our turbine powered reamer shoes. Interested to hear how we can assure hitting target depth first time. And we obviously already heard from Dave's drilling engineering perspective, how important that is to an operator in general, especially as these wells get longer. If something goes wrong in a 50,000 foot well, it's going to cost you a lot more than it would, back in years gone by when we didn't have the capability to drill to such depths. Now, we can drill to such depths, but how do we complete to these depths? That's another challenge altogether. We mentioned overcoming mechanical obstructions in open hole, like stringers, ledges, cuttings beds, and that's something that our turbines have been doing for the last 12 or 13 years with over 700 tools sold globally. From my personal background, we did mention the drill pipe swivel there. We have brought the MechLOK to the market. Now we have about 19 runs under our belt now with the MechLOK, and we have seen a variety of scenarios where our MechLOK has come in to be extremely useful and ensure that things reach target depth, that cleanup operations are accurate and well carried out, and wellbore displacements is another area where we've been working very hard with some of our customers. Now, why is a swivel in a well? Most of you know this. It's to ensure you can overcome case hole drag to successfully deploy a lower completion or liner to TD. Now, this is the main primary kind of headline function of a drill pipe swivel. You know, it allows you to rotate the upper drill string independently of the lower string and breaks the friction in the casing, gives you more available weight to slide to TD. Now, with these wells being drilled further and further, you know, having that available weight to get completions to the bottom of these extra deep, long reach, horizontal sections is very challenging. So these swivels allow you to get that available weight, also to mitigate against helical buckling, and it also ensures safety of your crew as well, with the mitigation against having to pick up lots of heavy walled tubulars, heavyweight drill pipe, drill collars, all that dangerous pipe handling and surface. You can ensure that your crew is safe, that we're doing it in a quick, safe manner, and we're reaching TD first time with the whole suite of deep casing tools technologies. So the equipment for the turbines for the bottom of the string, and the drill pipe swivel for reducing the case hole friction. And it'd be really cool to see these two work in tandem and help clients get to TD. Now, we originally launched the MechLOK probably in about 2019. And, you know, we originally had a right-hand locking tool. Very simple, works in compression when you run out of weight. And we lock it by simple mechanical manipulation to the right intention. Very simple, very easy, very quick as well, very efficient. It's very easy to lock as well. So you're not relying on balls and darts, seating, balls gravitating, balls getting caught up on square shoulders, for instance, which I've seen during my career. It's very simple, very quick. 2 minutes to lock it out. You're not relying on, you know, third-party equipment and, you know, basically in the lap of the gods at times. Now, we listen to our customers. Now, very much our view here at Deep Casing Tools is we don't try to put a square peg in a round hole. With the MechLOK, not one size fits all, unfortunately. So we've listened to our customers. You know, every customer has a different setup. Every customer has a different philosophy, how they like to do things. And, you know, working alongside a multitude of other service companies, because our equipment marries up with a lot of these other pieces of equipment in the well. So it's not only operational assurance for the operator, it's for the other service companies involved too. So your major service companies, your liner hanger providers, your running tool providers, your casing liner completion providers, because we don't want to accidentally cause any damage to these tools. So in 2020, 2021, we moved from a right-hand locking tool to produce a left-hand locking tool for a major Norwegian client, because they had a desire to lock to the left. And subsequently, we have just launched our new MechLOK T tool, which is driving operational assurance even further. Now, we are looking at some very exciting niche applications here, where we're doing a deployment of a lower completion and moving straight into a wellbore cleanup and open hole, sort of case hole displacement immediately after releasing from the casing running tool. Now, our MechLOK T allows you to swivel to the right in both tension and compression. So once we release from the liner hanger running tool, after deploying the completion to TD, we're going straight into a wellbore cleanup displacement, where we need to rotate at very high RPM without transmitting torque to the skinny wash pipe below, because that would twist off. And this allows us to get an efficient displacement in the case hole and saves a dedicated run to do a displacement and wellbore cleanup. Now, our functionality of the MechLOK T is absolutely ideal for this. And it also gives you that assurance that if you do get into trouble in the well, you can actually swivel pulling out of hole as well, and you're not stuck fast, and you can actually reduce the overpull and get your completion out if required. Touch wood, you're never in that situation. Also, we're launching our smaller 3.5-inch MechLOK T as well. Same functionality, just for smaller size applications. So, you know, if you're running through a 7-inch liner, deploying into a 6-inch hole, we've got you covered. And we're also working on another new version of the MechLOK, which is our MechLOK R, which is a ratchet style tool, which will be a permanent swivel to the right, in tension and compression, and will always lock to the left. So we're listening to our customers. We want to assure our customers that we have a tool for your job, no matter what your setup is, no matter what equipment you have in the well, we have something that fits you. We don't just have the one bog standard tool on the shelf, and we want to find the best fit for our customers and for the service companies and the major service companies involved in a lower completion deployment or a wellbore cleanup or a displacement. We work closely with our customers to make sure we're offering the best possible tool and service. So yeah, I think, you know, that covers, I would say, everything about the MechLOK and our new MechLOK T and our even newer MechLOK R. Thank you.
Thanks very much, Ian. We'll go on to the question and answer section now.
Sure.
So if you do have any more questions, please make sure to ask them through the Q&A section.
Don't be shy.
So one that I've got here, and I'll put it to Dave, is for the turbines, what sizes do they come in? I guess that's kind of, there's two answers there. It's the actual tool sizes and also the reamer heads that are available.
Yeah, I mean, we have various sizes, and they're the most commonly, they fit the whole sections where we most commonly have issues, which is normally in the 8.5, 6-inch and 12.25-inch hole section. So for our turbo caser, we have a 9 5/8 turbo caser, and we also have a turbo caser for 7-inch. These can both be drilled out, they're both drillable. Then we have our turbo runners, which are for final strings. We have ones for 8.5-inch hole, and we have for 6-inch hole, nominal 6-inch hole. We have a range of reaming heads, you know, so we can accommodate all the different variations of sizes for a 6-inch hole, you know, 5 3/4 up to 6 1/4, and an 8.5-inch. And with our TRS 700, we can go up to big, larger hole sizes, and these are customizable if you want to talk to us about what size, especially if you've got any strange sizes, you know, we can be flexible with what we can operate and what we can design and build. No problem.
Okay, thanks, Dave. Now the next one is for Ian. Where have we run the MechLOK T?
Well, thanks, Ali, for that one. Yeah, good question. So yeah, we run it first of all over with a super major over in Norway, where we actually ran the same single tool in all 3 laterals of a trilateral well. So that was sort of ERD style. And one of the big advantages of our tool over sort of competitor technology is we can reset and rerun our tool. You know, competitor technology has to be, once it's been in the hole, it has to go back to town for a redress. You know, it's costly logistic wise. So our tool, you know, especially with multilaterals, runs close together, remote locations as well. You know, that resetability and rerunability is a huge advantage. So yeah, we ran 3 times successfully. We ran into the open hole and did a lower completion drop off as well. And we have work lined up in the next 3 months here in the UK, and some further work over in Norway and across in Abu Dhabi. We'll be running both our larger and smaller size tools in the future with a bit of luck. So that's what we're looking at the moment. Yeah, thank you for that.
Okay, the next question that's come in, which is probably open to both of you, for both products, is which markets have you had the most success in? So maybe Dave, if you want to go first.
Okay, talking about the turbo runners and turbo casers, I think we've had success in pretty much every oil province. Of course, we do tend to operate in the places where we have the largest challenges. You know, in Mexico, there's a lot of issues there with faulting, fractures, geopressures. So we run a lot of turbo casers there. Very often we run a turbo caser as a final string, and just in case it doesn't get to TD and gets held up and we can't come out of the hole with it, that they can go back down and they can drill out and carry on in a smaller hole size. So again, that's talking about assurance for the final string using a turbo caser, which is drilled in the Middle East, of course, in the intermediate hole sections. There's the famous Naruma Shale. There's other formations there that can cause quite a few challenges, especially when you're at high angle, depending on your azimuth. We've had some successes there. Of course, we've had some issues, but on the whole, we can point to several runs with our turbo casers that saved the clients, and definitely they would not have got to TD without us in that whole section. And we assured that they got their casing to TD first time, and there was a big cost benefit there in quite difficult circumstances. Other areas, we're Eastern Europe. We've operated in the Far East, Sarawak, Malaysia. So basically all around the globe with our turbo cases and turbo runners. And very often we're going into a situation where they know that they're going to encounter problems, and that we've discussed it and we've planned the use of the tool. Sometimes we're being called out in an emergency because they're struggling, and we're providing equipment after they've sidetracked to ensure that they complete the well, now that they understand that the formation is not being very fair to them in terms of getting their tubulars to TD, and it needs some additional help. So pretty much everywhere.
No, it's a fair point, Dave, as well. And I think you mentioned that last minute calls. We had one there in Q1 where we sent one of our smaller turbo runners down to Italy. And the customer was having some big issues. We got a call over the festive period, and we made it happen. And I think that's a good thing here at Deep Casing Tools. We're small enough and we're focused enough on getting you to TD. This is our focus. Other players in these types of markets have many other tools. What's concerned about this is our prime focus, and we're small enough and flexible enough to make it work. We managed to get a tool sorted, got it down there. Our customer had to ream past 5 or 6 tight spots, and they got their lower liner to TD. So, these kind of last minute call-offs are common. Getting our customer to, employ our equipment from the beginning of the planning is the way to do it. And, following on, the success with the MechLOK, we've had successful runs. I mentioned Norway. We've done a couple of trilateral wells out there. We've had some runs in Abu Dhabi. We've had runs in Australia. Another trilateral down there as well. Malaysia with a very good run. We've got more runs coming up in Malaysia. It's a key market for us in the MechLOK. Here in the UK, we've had 2 runs with probably at least another half a dozen coming up over the coming months. So yeah, it's a wide range of marketplaces where we're operating in, and bringing operational assurance to all our customers globally.
Okay, thanks very much, Dave. Thanks very much, Eoin. There don't seem to be any more questions coming in. I guess that's probably a good place to stop for today.
Yeah.
Thanks very much, Eoin. Thanks very much, Dave, for your time. Thank you also to the viewers for tuning in to ask a question and see what we've got to say about ensuring operational assurance. I think it's been clear to see that from the technology and tools that we've got available, both in the construction and the completion phase, how we can help you get your operational efficiency and get to TD in one run. So thanks very much. And with that, I'll say goodbye.
Thank you, everyone.
Thanks, everybody.
Have a great day.